Hello everyone, welcome to my channel. Today I'm going to do another live coding screen recording of a standard problem called binary search. So this is the standard problem of binary search. Let's look at the problem quickly. Given a sorted array of integer numbers and a padded integer number, return the index of the padded number in the array. If the target does not exist, return -1. We must write this algorithm in an O log n runtime complexity. So this is a very standard problem for binary search. The important thing about this binary search is input array is sorted. If it is not sorted, we cannot do binary search. So here's the example. We have an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If the target is 5, return the index of 4. If the target is 11, because it does not exist in this input array, so return -1. So let's try to do the implementation. So for standard binary search, the key idea is we have our left index is 0, right index is nums.blanks, which is the last element. So while left smaller or equal to right, we look at the middle element. Middle equals to left plus right minus left divided by 2. So in this way, it will not overflow. Instead, if we write in the other way, called like int middle equals to left plus right divided by 2, if these numbers are too big and if the sum overflow of the integer of max, then it will overflow and it will become a negative number. By doing this right minus left divided by 2, we'll make sure that it will not overflow. So now we compare this number versus target. If equals to parted, return middle. Fine. Because if we have find this element, then we return the middle. Then we consider different cases. If the middle element is greater than target, else let's try to see if we did not find, return -1. So if the middle element is greater than the target, this means the target is on the left side of the middle element. So what we can do is we can set the right index equal to min -1. Else, if which means the middle element is smaller than the target. So this means all the element including the middle, all the element on the left including the middle is less than target. So we can search from the middle +1. So basically what we're doing is if this is every time we throw some elements away, right? If this one is too big, if the middle element is bigger than the target, so this means all the elements on the right side of the middle, including the middle element, can be thrown away. Because right now here is what we're doing is we will iterate through the whole array, and let's look at the edge case. So in the edge case, let's say right is left +1. In this case, middle will be equal to left. And in either condition, the window will be reduced to 1. So either right is moving to the middle -1, or left it becomes middle +1. So the window will be reduced by 1. And then right to left, they will be equal. And in this case, in the last case, when they're equal, then they will middle will be to one of the elements. It's the same because they're equal, right? So in this case, either they meet the condition or they do not meet the condition. And then because we have reduced the window to the last element, and if none of them match, then it will exit because either right will be middle minus 1, or either left will be middle plus 1. So in that way, the while condition will not meet, because before this, the last iteration, left will be equal to the right. So in this case, because at every step we are throwing away all the elements that is exactly not matching the condition. So each step, like, we are not missing elements. And if we are like reducing the window step by step, and at each step we are throwing all the elements that is exactly not meeting the condition, which means all the remaining elements is valid to search. And if we still don't find the element, then we can finish the iteration, and then we can say there's no element meeting the criteria. So now let's run this like test cases. So all the like smart test cases are like valid. So we find this element the index is 2, we find the element the index is 1, we find the element the index is 4, we cannot find this element in this array, we cannot find the element in this array, we find the element which index is 0, and so on. We are also trying to run this like random test cases. Yeah, all the random test cases also pass. So this means like our implementation is valid. So just quickly go through this like code. During the initialization, we initialize both left and right to the borrow elements, but they are both valid because we will evaluate both left element and right element. So left is 0 and right is num.less length minus 4. And during the loop, the condition is while left less than or equal to right, because both elements need to be evaluated. So like the condition is they need to be like less than or equal to. And during each iteration, we are throwing away all the elements that is embedded. And during each iteration, the window size will always be reduced by at least 1. So ultimately, there will be no infinite loop, and like the loop will always like break. So that's all for today's video. Hope you like it. If you have any questions, welcome to comment in my video. If you like it, my channel, you can subscribe to my video. I'm not an expert, but I'm trying to like improve by practicing. Thank you.